Hello, Matthews Gatos here. In this video, we are going to review inverse functions. I have 4 questions to cover. Question number 1. What equation represents y equals x cubed after it's reflected in the line y equal to x? So first of all, let's talk about the 3 types of reflections that we do. First type of reflection is reflecting in the line y equal to 0, the x-axis, which is a vertical reflection. Second reflection we do is to reflect in x equal to 0, which is the y-axis. That is a horizontal reflection. And the last reflection that we do is reflecting in the line y equal to x, which is the inverse. So this is just a way of asking you to come up with the inverse. Now, by definition of inverse, xy becomes yx, domain becomes range, range becomes domain. So if I have y equals x cubed, the first thing I do is interchange x and y. So to get y by itself, I would just take the cube root of both sides, and y is equal to the cube root of x. So that would be the inverse. So I can say that y inverse is the cube root of x. Okay, let's look at a graph here. So we have this graph of f of x, and we want to sketch the graph of the inverse, f inverse of x. So first thing is looking at the function f of x. Is it or is it not a function? I can determine that by using this vertical line. So as I slide the vertical line across the function, I'm looking to see, does it intersect more than once? And it does not intersect more than once, which means it passes the vertical line test. Therefore, it is a function. Now, what we could do is we could also determine if the inverse is the function. So to determine if the inverse is a function given the graph of the function, I don't use a vertical line test because that's for functions. On the function, I can use a horizontal line test. So as I slide that along, I see here it fails the horizontal line test. It also fails it here, which means that the inverse, without even graphing it, is not a function. But we'll come back and verify that once we graph it. Okay, so just to finish off with the function here, the function f of x has intercepts at, well, we can see it has an x-intercept at -6, 0, and it also has a y-intercept at 0, 4. Now let's talk domain and range of this function. Domain goes between -6, right here, and +6. So the domain is in between negative and +6, but still an element of the reals. For the range, I look at my y values. So I can see the range goes from a low point of 0 to a high point of 4. So that means my range is a set of all y such that y is greater than or equal to 0, but less than or equal to 4. Okay, let's sketch the inverse now. So inverse says take each point xy and it becomes yx. So this point -6 and 0 is going to become the point 0 and -6. The point -4 and 4 will become the point 4 and -4. If I have 0 and 4, switch the x and y around, I get 4 and 0. 2 and 2, if I switch that around, it stays as 2 and 2. So this is an invariant point, which means it does not change. The point 6 and 2, when I flip that around, becomes 2 and 6. So then all I have to do is connect my dots, and that would be my inverse. So this is the inverse of f of x. So we already said it is not a function because we looked at the original function and it failed the horizontal line test. Now that I have the graph of the inverse, I can use the vertical line test on the graph, and I can see it fails here and it also fails here. So it's just verifying the fact that it is not a function. So to finish this off, let's look at the important parts of the inverse. So the intercepts, since everything is switched around, this x-intercept becomes a y-intercept, and I can see that that is the case. This y-intercept becomes an x-intercept, which I can see is also the case. So anything that is true for x is true for y, and vice versa. The domain is going to be the range. So that's going to be between 0 and 4. And I can see on my graph, if I come up here, I am going between a 0 and a value of 4. So that is correct. And my range is going to be the domain of the original function, which is in between -6 and +6, which I can also see. Low point of -6 there, high point of +6. So now you can see graphically as well that for an inverse, domain becomes range, range becomes domain. Let's look at this question. This is a classic diploma question, so star it so we can come back to it when we review. We have this function f of x, and we want to know right now, if I were to take the inverse, it would not be a function. I can see that it fails the horizontal line test in multiple points. So a common question is, how can you take the original graph of f of x, restrict the domain to ensure that the inverse is also a function? Okay, so let's look at the options that they have. So my first option is that I could restrict it so that x was from -3 to +infinity. So that means I would start at -3 to +infinity. So I would be looking at this part of the graph. So if you look, that does nothing to make me pass the horizontal line test. So that is definitely not an option. Let's look at option B. B says to go from -infinity up to 2. So from -infinity up to an x value of 2. And you can see that does not do anything to help me pass the horizontal line test. So that is also not an option. Option number C says go from -infinity to +1. So let's try that. So from -infinity to +1 would be this part of the graph. But I can see that also does not pass the horizontal line test. So that won't work either. Hopefully the last option works because that's all we have left. It says that x has to be from 3 to +infinity. So here's 3 to +infinity. So if I slide my horizontal line along that, yes, it passes. So I know that D has to be my answer. Okay, last question, number 4. In this one here, I have a quadratic function, -2 x minus 3 squared plus 8. I want to determine the domain and range, not of that, but of the inverse. So we don't necessarily have to graph the inverse to know what the domain and range is. We just have to look at the original function. So I know this original function is a parabola that opens down with a vertex of +3 and +8. So let's use interval notation this time. I know that the domain of every parabola is from -infinity to +infinity because these arms extend infinitely in both directions, covering all the horizontal x values. My range, since it opens down and I have a maximum, is everything 8 and below. So my range is going to be from -infinity up to, but including 8. So we'll lock that in. Now it stands to reason that domain and range interchange. I don't need to do the graph, but I'll show you the graph of the inverse just so we can verify that that is in fact true. So my domain from -infinity to +infinity will now become my range. Let's see if that works. So I can see these arms extend infinitely in both directions, covering all the vertical values of y. So that does work. The range of the original will now become the domain. So from -infinity up to and including 8. I can see there's my x value of 8 and everything is to the left of 8. So I know from -infinity up to +8, that works as well. So I hope this review of inverse functions helped, and I look forward to seeing you for our next video.